The data came back at 3:47 in the morning, and the astronomer staring at the readout didn't sleep after that. Because the numbers coming off 3I Atlas, after it passed through Jupiter's gravitational field, did not match. Not off by a little, not a margin of error problem. They didn't match in a way that has no clean, natural explanation. I'm going to show you exactly what those numbers are, exactly what they mean, and exactly why the people who study interstellar objects for a living are having a very hard time explaining them away. But I'm not going to tell you the conclusion yet, because if I do, you won't understand why it matters. You need to see the whole picture first. So stay with me, because by the end of this video, the last 2 minutes specifically, you are going to understand something about what just happened in our solar system that most people will never hear about. Real quick, before we go any further, where in the world are you watching this right now? Drop it in the comments. City, country, time of day, whatever. I read every single one. And honestly, one of the things I love most about this channel is that we have people watching from places I'd never expect. Someone last week was watching from a research station in Iceland. So yeah, tell me where you are. All right, let's go back to the beginning. On July 1st, 2025, the Atlas Telescope Network detected something moving through our solar system that had absolutely no business being here. It was coming in fast, too fast, moving at a velocity that ruled out any origin point in our solar system. It had to have come from somewhere else, another star system, somewhere across the void. And by the time it reached us, it had been traveling for what scientists estimate was hundreds of millions of years. They called it 3I Atlas, the third known interstellar object ever detected passing through our solar system, the third visitor from outside. The first was Oumuamua in 2017, shaped like nothing we'd ever seen, flat, elongated, accelerating in a way that ice outgassing couldn't explain. Scientists are still arguing about what it was. The second was Borisov in 2019. That one looked more like a normal comet. People relaxed a little. Maybe Oumuamua was a fluke. Then 3I Atlas showed up, and it is not like either of them. For months after its discovery, every major observatory on Earth and several in orbit was pointed at it, and the data kept coming back strange. The brightness fluctuated in patterns that didn't fit standard comet behavior. The coma, the cloud of gas and dust that normally halos a comet, was there, but its structure was unusually organized. Too organized. Like the jets of material coming off it were emerging from specific fixed points rather than spreading randomly as ice sublimated across the surface. But the detail that kept coming up in every pre-flyby briefing, the one that researchers kept circling back to, was the mass. 3I Atlas has a mass of approximately 1 billion metric tons. That number sounds big because it is. But what makes it truly alarming isn't the size of the number, it's what that number means when you compare it to the other interstellar objects we've detected. Oumuamua, the first one, had an estimated mass of about 10,000 metric tons. 3I Atlas is 100,000 times more massive than Oumuamua. Here's the problem. In nature, when you look at asteroid populations, comet populations, debris fields anywhere in the galaxy, small objects vastly outnumber large ones. For every object the size of 3I Atlas, statistics say we should have detected hundreds of thousands of Oumuamua-sized objects first. We haven't detected any of them. The Vera Rubin Observatory, the most powerful sky survey telescope ever built, which went fully online in early 2026 and can generate up to 7 million sky alerts per night, was specifically designed to catch objects like this. If the smaller interstellar visitors exist in the numbers the math demands, Rubin would be finding them every few weeks. It's not finding them, and that silence is as loud as anything 3I Atlas itself has done. But none of that, none of the pre-flyby strangeness prepared anyone for what happened on March 16, 2026. On that date, 3I Atlas passed within 33.3 million miles of Jupiter. That's close. enormously close in astronomical terms. Close enough that it crossed into what scientists call Jupiter's Hill sphere, the invisible gravitational boundary where Jupiter's pull takes over from the Sun's, the zone where Jupiter is king. Jupiter is 318 times more massive than Earth. Its gravity doesn't just tug at things, it compresses them, twists them, breaks them apart, or flings them across the solar system like a slingshot. 3I-Atlas flew directly into that environment, and the Juno spacecraft, currently in Jovian orbit, was watching every second of it. What Juno recorded during those hours is what brought us to this video, and I promised you I'd get there. We're almost there. But first, there are 5 specific things about 3I-Atlas that scientists cannot explain. 5 anomalies that existed before the flyby, and which the flyby data has now made significantly harder to dismiss. You need to know all 5 before the final piece lands the way it should. The jet structure. When comets heat up near a star, ice sublimates and jets of gas and dust burst through weak points in the surface. It's chaotic by nature. The weak points are random, the jets are irregular. That randomness is the fingerprint of a natural object. 3I-Atlas has jets, but they're not random. Spectroscopic imaging shows them emerging from geometrically consistent positions with near-identical emission intensities, at angles that are, in the most careful language researchers are willing to use publicly, inconsistent with standard sublimation models. That's not a fringe opinion, that's in the preprint literature. Anomaly 2. The rotation. Natural comets tumble. They spin in complex, often chaotic ways because they've been through billions of years of gravitational nudges, collisions, and outgassing forces. Stable, consistent rotation in a small body is unusual. It requires either extraordinary luck or something stabilizing it. 3I-Atlas has an unusually stable, consistent rotation period. It is not tumbling. It is spinning cleanly, like something that was manufactured to maintain a specific orientation, or something that has an internal mass distribution so precise that chance stabilized it. Possible, but unlikely. Anomaly 3. The trajectory into our solar system. 3I-Atlas did not approach from a direction that matches any known stellar nursery, nearby star system, or high-density interstellar cloud. Its inbound path traces back to a region of space that is, statistically, one of the less likely origins for a naturally ejected comet. Natural comets get kicked out of their star systems by gravitational interactions with giant planets, usually during the chaotic early formation period of that system. The directions they travel afterward are somewhat predictable based on their origin. 3I-Atlas's origin direction doesn't fit the pattern cleanly. It's not impossible, but it's another thing that requires an explanation that nobody has found yet. Anomaly 4. The spectral signature. When scientists analyzed the light bouncing off 3I-Atlas's surface and coma, they found chemical signatures consistent with very old, very processed material. Not unusual in itself, interstellar objects are ancient, but embedded in that signature were absorption lines suggesting carbon compounds of a complexity and organization that some researchers have described as difficult to account for through purely abiotic chemistry. In plain English, the chemistry on this thing looks more organized than random interstellar processing tends to produce. Not impossible, but it's the 4th anomaly on a list that keeps growing. Anomaly 5, and this one is the one people aren't talking about enough. The deceleration signature. In the weeks before the Jupiter flyby, very precise astrometric measurements of 3I-Atlas's position were being taken by multiple independent observatories. And when they ran the numbers, when they modeled exactly how 3I-Atlas should be moving based on all known gravitational influences, they found a small but statistically significant deviation. The object was experiencing a non-gravitational force. Something other than solar radiation pressure and known comet outgassing was influencing its path. The magnitude was small, but it was consistent, and consistent, unexplained non-gravitational acceleration in an interstellar object is precisely the anomaly that put Oumuamua on the map in the first place. 5 anomalies, each one individually explainable, maybe. All 5 together, that's a different conversation. And then came the flyby. Here is what the post-flyby data shows. When 3I-ATLS passed through Jupiter's Hill sphere, through the most intense gravitational environment in our solar system outside the Sun, it experienced exactly what physicists predicted it would: tidal forcing, gravitational compression, the kind of stress that should have left measurable marks. Specifically, for a natural comet of its estimated mass and density, the flyby should have triggered one of 2 things: either a measurable increase in outgassing, ice and volatile materials cracking and venting under the stress, or visible surface fracturing detectable through changes in the object's brightness curve. Neither happened in the way the models predicted. 3I-ATLS passed through Jupiter's gravitational gauntlet, through forces that have torn apart natural comets that got nowhere near as close, and emerged structurally unchanged. No significant outgassing spike, no brightness disruption consistent with fracturing. The object that came out the other side of that encounter looked, in every measurable way, exactly like the object that went in. Now, I want to be precise here because this is where it matters. 2% is not 0. It's unlikely, but it's not impossible. A very dense, very solid natural object, more rock than ice, structurally cohesive in a way we rarely see in comets, could survive that encounter. It would be unusual, it would be another anomaly on the list, but it wouldn't by itself prove anything extraordinary. What makes this different is the trajectory. When scientists modeled 3I-ATLS's post-flyby path, the gravitational slingshot component from Jupiter, they found that the trajectory bend was not consistent with a uniform density object of its estimated mass. The bend was off. Specifically, it was off in the way it would be if the object's mass was concentrated toward its center, rather than distributed evenly the way a natural comet's would be. A dense, heavy core, lighter exterior. That's the mass distribution the trajectory data implies. That is also, incidentally, the mass distribution of a constructed object, a shell, a vessel, something built. For a loosely packed natural comet of its mass subjected to those tidal forces at that proximity, the probability of that outcome, according to the modeling, is less than 2%. Let me be clear about what I'm not saying. I'm not saying 3I-Atlas is a spacecraft. I'm not saying we have proof of anything. The data has alternative interpretations, and serious scientists are working through all of them right now. What I am saying, what the data genuinely supports, is that every single anomaly we've observed on this object points in the same direction. The geometry of the jets, the stable rotation, the unexplained non-gravitational force, the complex chemistry, the survival of tidal forcing that should have broken it apart, and now a post-flyby trajectory that implies a mass distribution no natural comet has any business having. At some point, and serious astronomers, including Harvard's former astronomy department chair, are saying this publicly, you stop treating each anomaly as its own isolated puzzle, and you ask what single explanation would account for all of them at once. The Vera Rubin Observatory is still running. It will find more interstellar objects, and when it does, if the small ones keep not showing up, if every visitor we detect is massive and anomalous and strange, then the statistical case that we are looking at something natural is going to get very, very hard to make. 3I-Atlas is on its way out now. Jupiter gave it a final push toward the exit, and it's leaving. Whatever it is, rock, comet, or something we don't have a category for, it came from somewhere else, passed through the most violent gravitational environment in our solar system, and came out the other side unchanged. That's the detail the astronomers staring at the readout at 3:47 in the morning couldn't let go of. I don't blame them. If this gave you something real to sit with, hit the like button. It genuinely helps this kind of content reach people who want to follow this story. Subscribe to Space Aquarius, because the Vera Rubin data is ongoing. The 3I-Atlas trajectory analysis is still being published, and this story is not finished, not even close. And drop a comment below where you're watching from and one word for how this leaves you feeling. I'll read every single one. I'll see you in the next one.